Hello, everyone. Good morning, good day. Thank you for joining us in our short webinar on polarization and its application. My name is Friederike Marschalk. I'm the head of marketing and sales here at codixx. If you have any questions after the webinar, please feel free to reach out, either by phone or by email. A few quick rules at the start. Please let your camera and microphone switched off. If you have any questions, please type them in the chat and I will answer them in the end with our Q&A section. So let's get started. So what is light? So light can be described as a transverse electromagnetic wave that oscillates transversely to the direction of propagation. It makes a little bit more sense if we look at a little bit of an animated graph. So here you can see the electric component and the magnetic component oscillating along the z-axis. So then what is polarization and the different state of polarization? So polarization is basically a property of transverse waves that specifies the orientation of these oscillations. So then we have the state of polarization, which basically just describes the different geometric orientation of the electric field oscillations in the electromagnetic wave. So we have natural light, where there isn't really any order. So you have all different kinds of orientations. You have partially polarized light. You can have fully polarized light. And for the polarized light, we are also discerning between linear polarized light, circular polarized light, and elliptically polarized light. So for a linear polarized light, you can see here the electric field vector oscillating along the direction of propagation, and it just oscillates in one plane. For the elliptically polarized light, this is actually the most general state. The field vector traces an ellipse, a combination of the unequal linear components. So as I said, this is the most common state in natural light after light interacts with a surface or a B reference. Basically, all around us, there's polarization happening due to different circumstances, resulting in this elliptical polarized light. Then you have the circular polarized light, which is kind of a special case of the elliptically polarized light. So the field rotates in a circle as the wave propagates. It could be right-handed or left-handed. So this is actually pretty common in satellite communications, just to avoid signal loss if the receiver rotates. So as I said, natural light can be sort of as a mixture. It's a superposition of countless linearly polarized lights. You can see here is a different, just an example of the different oscillation directions. And we can see here, so we have the partially polarized light over here. Somehow it got lost. So you have always the natural light, linear polarized light, circular polarized, elliptical in these different states. And this is where the degree of polarization comes in. So if I'm talking about the degree of polarization, it just means how much of polarized light is included in the total light. So if I have perfectly linear polarized light or elliptical polarized or circular polarized, So the degree of polarization P equals 1. So for a purely natural light, P would be 0, as there is not really one certain polarized part in the light. And then we have the partially polarized light, where P is somewhere between 1 and 0. So, and now for polarizers. So how can I generate polarized light? There are a few different options to do that. You have dichroism absorption, you have birefringe, reflection, refraction, or scattering. It happens naturally all around us. But usually if you're working in a certain application or in a lab, you want to control it. So you need a polarizer. I have an example here for an absorption type polarizer. You have all these different field vectors going in. You have the polarization axis of this polarizer, and only the E vectors along these polarization axis can pass through. Everything else will be absorbed. Yeah. So why would you need the polarized light? Well, actually, there are a few different things that you can do with a polarizer. And what can you do actually with a polarizer? So a polarizer has 3 basic functions, which can then be utilized in different applications. For example, you have the polarizer mode, where you can enhance the polarization ratio. For example, of lasers, you can use this in optical communication, in a fiber, in calibration, alignment, or in illumination. Then you can use it in an analyzer mode. You can check what kind of polarization does this light have that I'm currently working with. That's used in analyzing microscopy, spectrometer, polarimeter, or photo elasticity. For example, in the stress measurement, like in this small ruler here, you can see, thanks to polarization, the different stress in the translucent material. Then we have the block mode, where you can block certain types of polarization, and you can reduce reflections. That's where it's used often in imaging applications or surface inspection. Everyone who is hobbyist in photography probably knows this one best, as it's often used in photography to photograph through a glass surface, or to enhance the contrast ratio to get a really blue sky, or in California to see the crocodiles, or no, that's Florida, the crocodiles in the water. So this is just a simple application, which I think shows really good the polarizer mode and analyzer mode. This is a polarimeter, and at the start you have the light source, which emits ordinary light. And then you have a polarizer, which allows only one plane of the field vector to go through. And then you have the sample cell, an optical reactive material, which rotates the polarization. And then at the end, you have a different polarization field vector than the one you had to go in. And because the human eye can't really see the polarization, so you need an analyzer, a second polarizer in the end, which you can rotate to find where did the polarization axis change to. So this is used, for example, in sugar measurement, because the more sugar you have in the solution, the more the polarization axis will be rotated, and it can be used to estimate how much sugar is in a certain application, in a certain sample. So now a little bit of a final note, because I'm working in sales. So codixx was founded in 1998. We are located in Germany. We are basically, polarizer manufacturers. We do really highly customized polarizers for UV, visible, and infrared. Below in the picture, you can see a teeny tiny sample of a few products we've made. We make single pieces, large orders. We are have a certified quality according to the ISO 9001, REACH, RoHS, POPs, etc. If you have any more questions on this area, feel free to visit our website. Otherwise, thank you for your attention. And if you have any questions, I'm looking at my colleague. Did we have any questions in the comment section? No, we didn't. All right, then I don't really want to keep you much longer. Just stay tuned for our next webinar in March. We'll be on polarizers in quantum optics. Very interesting topic. Or along the year, I also talk about what different types of polarizers are there and which type to select for which application in April. Or we are specialized in pattern polarizers. So the question is, what can they do for you? I'll answer that in May. And in June, polarization axis accuracy. Why is it important in certain applications? There will be more topics. If you have any specific topic you are interested in, please let us know. Otherwise, okay, I see there is a question. I found this polarizer for infrared and are expensive and poor performance. Is that still the case? Well, it depends on what kind of polarizer you are using. And of course, also in which wavelengths range you're using. So for infrared, if you're using the film polarizers with a polymer film, they are not so good. I don't know. Have you tried out our polarizers? I think they do have a pretty good performance in the infrared. Feel free to reach out, or I can get in touch with you, and we can talk about this in detail at a later time. Would that work for you, Christoph Meyer? Then thank you for your time today, and see you hopefully next month. Thank you.